Welcome everyone to Intro to Python in OP. So let's go ahead and get an overview over what we're going to be going over today. Today we're going to be going over object-oriented programming, which stands for OOP. We're going to be going over classes in Python, how to build a class, instantiating objects with init and self. Don't worry about what init and self necessarily mean right now. I'll go over it once we're actually building code. And then we have our instance methods, self, and Dunder methods. And again, these three last points will make more sense once we're actually seeing some code. All right, and then just to clarify, you will be tested over the concepts taught in today's lesson on assessment 1, not assignment 1, at the end of this week. All right, does anyone have any questions over what we're going to be going over today? Perfect. All right, so what is object-oriented programming? Can I get somebody to read this slide, please?
Sure. Object-oriented programming is a programming approach that organizes code around objects, which are representations of real-world entities. It focuses on breaking down complex problems into smaller, manageable pieces called classes that have properties, attributes, and behaviors, methods. By using OOP, we can create reusable code, promote code organization, and simplify problem solving by modeling the relationships between objects.
All right, awesome. Thank you so much, Grace. I'm glad you added that because honestly, my second grade reading level would have been terrible at reading this to you guys. So let's keep pushing forward. All right, so what is a class in Python? Well, in reality, a class in Python is basically just a blueprint, right? So we have this nice little image of an iPhone blueprint. I'm not sure if it's a real iPhone blueprint, but it looks pretty cool, so I put it on there. And basically, it's to give you guys the idea that the class in itself isn't an actual object or something that you can utilize, but the class is just a framework. It's something that you map out so that you can make things, right? And so the class is just exactly that, just the actual blueprint saying, this is what I expect this method to be able to do. These are the attributes that I expect this method to have. And an instance, well, an instance is the actual thing once it's made. So once you instantiate the actual class and pass out all of the arguments that you need to pass into it, right, it's like creating a character in D&D. That's a very good analogy. Thanks, Roger. Once you actually pass all the information that it needs and put it in its nice little casing, well, now you have an instance, right? We are more than likely all of us have phones. We'll think about the blueprint to creating a phone as the class, and then every single one of our phones are instances, and each one of them are different in their own way, whether it be the applications that they have. If somebody has an iPhone or someone has an Android, they have different features that are available into their phones. And that's just the difference in between instances. So those are classes and instances. Does anyone have any questions over what a class is and what an instance is? Okay. All right, so let's go over the 4 pillars of OOP. We have encapsulation, abstraction, inheritance, and polymorphism. I've been on a couple of interviews where they've asked me for the 5 pillars of OOP. And if they ask you for the 5 pillars of OOP, the only extra one is composition, but it's not really its own pillar. We'll go over that later on Thursday's lesson. Actually, Friday's lesson. Nope, Thursday's lesson. Sorry about that. All right, so encapsulation and abstraction. Encapsulation basically just means that a specific data can be restricted from the rest of your code. So let's say, again, we have our example that we have our Apple ID. Or we have our iPhone. Well, I want to change my email that's registered to my Apple ID. In order to do that, I can't just grab my email and tell it this is what the new email is and save it. It has to run through a password confirmation, and then usually it asks us for 2 methods of confirmation before actually overriding that email that's tied to my Apple ID. Well, that is a way of encapsulation. It's making sure that that information is restricted from me to touch or alter, and it specifies a specific method for me to be able to do that information. All right. And then abstraction. Abstraction is logic and complexities hidden from for simplicity. So again, if we're still using the iPhone, when I turn on my screen, I have no idea how everything behind the iPhone is actually working. I don't know how much the computer within my phone is sourcing energy towards like all the lights that make everything happen, how it's registering the code from me touching the screen. All of that information is not available to me, and it's because I really don't need to know about it. Right? All I need to know is that if I click this icon on my screen, an application opens up and it works fine. That's abstraction. All right, so now we have inheritance and polymorphism. So inheritance, and this is specifically why I chose the iPhone, is because the iPhone is essentially the same every year or every time they come out with a new one, but they add maybe just one or two extra features, right? And those one or sometimes they're not even one or two extra features, they're just the same feature, but they work in a different way. And they, that's how they say that they're making something new. Well, that's inheritance, right? They're not necessarily restarting the entire framework for making a new phone. Instead, they take the old phone and they change it by giving it to a newer model or a newer blueprint. But this newer blueprint now has a couple of extra attributes or a couple of extra methods that you can use, right? And then polymorphism, that ties in with inheritance because let's take, for example, the camera. The camera is always available in all of the phones, right? In all of the iPhones. But the camera gets better every single time. So the method, right, or the behavior, which is a method of taking a picture, changes every time. The action of taking it, yeah, it works the same, but the end result is different. All right. Okay, and that's the 4 pillars of OOP. Does anyone have any questions over the 4 pillars of OOP?
Just for my note taking, what was that possible kind of half-fifth one that you said?
One more time.
For my note taking, you said sometimes they ask about the 5 pillars of OOP, and you're like, it's kind of a fifth pillar, but not really. What was the fifth one again?
Composition.
Thanks.
Of course. All right, so that's the last thing we have is going and seeing some code. So let's go ahead and do that. I think it's left. Let's see.
Yeah, it's good we're seeing code now. Just for anyone watching, this whole like 5 pillars thing, none of those are really going to make sense until you see it directly, like what it actually is. So it'll make sense soon enough. At least most of them. Like composition, you'll know. Okay, that's a specific thing.
Nice. Okay, so let's go over today's notes. Well, today we already went over all of this material in the lecture PowerPoint. We haven't covered self really, but let's actually try to concentrate on doing some code first before we do anything. So if we're sticking to our actual example that we provided in the slideshow, well, let's say we're talking about a phone, right, or an iPhone. So let's go ahead and I make my class, and then I call it iPhone. So notice the very first letter inside of a class is capitalized. That's something standard. Every time you make a class, you want to make sure the first letter is capitalized in Python. All right, so then I use my colon, and there I'm saying this class is going to exist, and I need my program to be able to acknowledge that it exists. But I'm not actually initiating anything nor doing anything with it. So I actually need to create a method for initiating the class. And that's what this init method is doing. It's telling my class, hey, this is in order to make this class, this blueprint into an actual instance, this is the material or information that I need, right? So self is the first argument that we have to pass, and self is in reference to the class itself, right? So any argument passed inside of this function is going to be referencing to the iPhone or the instance. Well, it will be referencing to the instance that gets created. And I'll clarify that here as soon as we make an actual instance. So let's say the iPhone has an owner, right? Well, it also needs to have a phone number. And what else can I have? I guess brand. Let's go with that. Or model would be better. Okay. So notice it works just like a function. I'm still using the def keyword to establish a function. The difference is that I'm passing the init method, right? And it knows that it's an init because it belongs to a class. Self is already highlighted even though I'm not using it. And then these three are just the arguments that I need to pass when I create an instance. So now I actually need to give the iPhone class its attributes. So I'm going to say this instance of the iPhone class, self owner, is going to be equal to the owner. I can say the self phone number. And we see how it's not recognizing it, right? And that's because it knows that when I say self period something, it's saying, okay, well, this instance or this class, when I say self, does it have whatever he's starting to type out? It doesn't. But on the right side, when I start typing out phone number, it autofills because it knows that it's not looking within the class, it's looking at the arguments being passed into the function. Nope, that ain't it. Okay, so just like that, we established a class. All right, so this is the init method. This is how it works. But now let's go and actually create an instance so that we can visualize it. Well, I can say my phone, and then I can make that equal to the iPhone. All right, again, I don't need to pass in self. It is going to need an owner. So I'm going to pass in Francisco. It's going to need a phone number. So I'll pass it in as a string. So okay, and then last, it's going to need a model. So let's just say, let's go with 6, and I'll make that one into an integer. Okay, so that is how you initiate a method. How come it is self.owner and not self._owner? Oh, did somebody already answer that? Okay, thank you so much. Yes, we'll be going about private attributes and getters and setters. And we'll be covering that tomorrow. This is covering the basics of being able to initiate a class. Okay, perfect. So now I have my phone, right? And it's going to know that the self.owner or my iPhone.owner is going to be Francisco. It's going to that my iPhone.phone number will be the phone that I'm passing here. And my phone.model would be 6. So I could actually go ahead and print those things. Let's say my phone.owner. I'm just going to go ahead and say owner here.
Can I set those properties using bracket notation?
Yeah, so I'll cover that right now. Thank you so much for asking that. So his question was, can we access these properties using a bracket notation? And we all remember how we established a dictionary. So let's say a phone, right, was instead a dictionary, and it had like owner and and then the owner was Francisco, and so on. Well, if I wanted to access a phone as a dictionary and access it through bracket notation, I could because it's a dictionary. But when we're talking about classes, we always want to use dot notation. And dot notation is actually going to stay pretty consistent when we're using more complex programs. For example, when you're working with importing and exporting inside of Python, you're always going to use dot notation instead of using bracket notations. Does that answer your question?
Yeah, thank you.
Of course. Okay, so now let me run this example now. Okay, so we see that the owner came out to be Francisco. And is this font too small? Do I need to zoom in? Let me just zoom in just in case. We see the owner comes out to be Francisco. The number comes out to be exactly what I passed in. And the model comes out to be 6. Okay. So that works great. But now let's say that I wanted to do something like just view the entire thing. Well, I wonder what happens if I print my phone. Well, if I run this program, now we can see that phone has this object and it's saying that it's part of main, and then it has this complex number back there. Well, this is just the number that's representing this specific instance behind the computer, right? So for example, if I instantiate another one, so let's say a phone, and let's say I make this also an iPhone, but now I have Benjamin, and then let's say the number is 777, 777, 7777. And then finally, the model is 9. Okay. So now if I were to run something like a comparison saying, hey, is my phone equal to a phone? It's going to tell me that it's not. It's going to tell me false, even though they're both the same class. It's going to tell me false, not because of the arguments that I passed into it, but because of the way it saves itself in the computer. So what it's actually doing is it's comparing this, I don't want to say encrypted because it's not encrypted, but it's saving this memory space or its memory location, and it's running it against whatever it is that I'm passing it. Oh, thank you, Nick. So if I print a phone here, and now I run it, we see that it's almost exactly the same, but then when we get here into the actual number where it's located, they're different. And that's instantiating multiple instances. Okay. So before I keep moving on forward, does anyone have any questions over how to declare a class, how to work with the init method, and how to instantiate a class?
Could you repeat what you said about using dot notation? Like when you said when accessing a class, or
Yeah, whenever you're accessing anything within a class, you're going to be using dot notation. And as we start using more complex things inside of Python, you'll see dot notation become more and more common. In about 2 weeks from now, we'll start working with Django to create our API. And in Django, we'll strictly use dot notation, and we won't be really utilizing any type of brackets unless we're working with an API, with a specific API. Does that answer your question?
yeah, so just stick to dot notation unless you're using like a dictionary or some type of other data structure. Like
Yes.
if there was a dictionary within class iPhone, like would you access that through brackets?
So you're saying, for example, if I had something like contacts, right? And then, oh, I don't want to make that self contacts. And then it was something like this. Well, I could just enter the actual dictionary. So let me see. So we got contacts. Thought you have to use brackets with an object if the label is a string with a space or something. I'll have to get back to you right now, Dave. Let me answer this question real quick. So I would still have to enter the actual contacts itself through dot notation. But then after that, let's say I wanted to enter names. Well, then I could use something like this. Oh, and it actually gives me an error, so I can't do that. Let's see. Okay, so we see that contacts and it gives me the dictionary in itself. As far as entering this dictionary, you may have to save this to a variable. So let's say contacts is going to be equal to my phone dot contacts. And just because I'm sure there's going to be a name of question about it, if I try to run dot name, we'll see the error pops up saying, hey, dot name doesn't exist. But what I can do is save the dictionary to a variable and then access contacts this way. And now we should see a list. Does that make sense, Della?
Yeah, that makes sense. Thanks.
Of course, no problem. Okay, seems like the chat's getting quite a bit of noise. Yeah, so there's a lot of white noise in the chat, and for me to filter out is going to take a while. So if you have a question, could you please just ask it out loud from now on?
The contacts, is that constant across the board for every class you make afterwards? Without having to put extra input into the as an argument?
Yeah,
or
so we see that context doesn't have anything, isn't being passed through the init method, right? So what I'm saying is this attribute across every single class instantiated, so every single time I instantiate this class, this self.context will always start out with a dictionary with the key of name and the list right afterwards. Does that answer your question, Roger?
yes, and does every class require the init defining it as the very first one or no?
Yes, so every time you instantiate a class, you want to use the init method. The only time you won't do this is if it's a pre-built class that's been provided by Python. But although you yourself are not making the init method, Python already did it for you, and it's just keeping that information away from you. Does that answer your question?
Yes, thank you.
Of course.
I just wanted to say, when you were trying to access the list, where you were typing in myphone.contacts and then bracket, you put inside of the quotations, you had put names, plural, and it gave you the error.
Oh, did I really? Let me see. That's what I get for not paying attention. Thank you. Okay, yeah, so I can access it this way. Something that I do want everyone to start practicing though when they're working in Python, try not to use this bracket notation. Instead, use the .get method, especially when you're working with dictionaries, because as we saw, if you run the bracket notations, so it works exactly the same, right? But if you run the bracket notations and that doesn't exist, it's going to break your program. So if I change it to names now, it doesn't exist. So instead, it's just going to return none, right? It didn't cause an error or break my program. It returned none. So start trying to use the .get method and try to avoid using the bracket notations, because obviously if you use the bracket notations, it's going to cause more errors than necessary. All right, so now we got this part. Okay, before I keep pushing on forward, again, does anyone have any questions over instantiating methods and how they work? I've missed the explanation, but what does self do, or what is its function? Okay, right, so we see how here I have self.owner, right? Well, self is actually taking the place of whatever variable I assign to the actual class. So now we see my phone.owner, right? Just as we did here on self, and it's actually printing whatever it is that I pass as an argument, right? So self is in reference to the instance of the class. Does that answer your question?
Yes, thank you.
Okay.
I got another question, Francisco.
Yeah, of course.
So when we instantiate, once we're done using it, do we have to like de-instantiate it to free up memory?
As long as the actual script is still running, it is going to continue to live. As far as getting rid of it, I think you can run the .delete. Let me make sure. No, that's not it. Yeah, that's a good question. I've never actually tried to delete a class. But this isn't occupying memory inside of your computer like forever. Once the script is over, it goes away. Does that answer your question, Kelvin?
Yeah, thank you.
Yeah, that question tells me you obviously have some experience in a language like C or something. That very idea of explicitly allocating memory and then telling the computer when you're done with something, it can now free up that memory. And if you don't do that, even if the program ends, that is occupied memory forever. That is not a concept in modern languages like JavaScript or Python. It's doing it all behind the scenes for you. You never have to explicitly deallocate memory.
Yeah, and I see it on the chat. That's called a garbage collector. There's some languages that won't do it automatically for you, but Python and JavaScript will.
Thank you.
Yeah, of course.
I have
A
one
quick question, Francisco.
Yeah, go ahead.
Can you just explain one more time the difference, between defining like contacts down there versus passing it in as a parameter, and how you can access them, or like functionally how they behave differently in a class?
Yeah, definitely. So we see that I have this class and I'm passing in all this information, right? Well, my phone my phone and a phone, they each have different arguments that were passed. So passed an owner, phone number, and model. I never told my init method that I would need to receive a contacts. So I know that every phone is going to need a section where they can store their contacts, right? Well, now I can go ahead and print my phone.contacts, and then I can also print a phone.contacts. And when I run this, you'll see that they're both exactly the same. They both come out with exactly the same thing because that's what I passed into it. But every single other argument is different. So if I try to access the owner for my phone, I'll see Francisco, and the owner for a phone will be Benjamin. This is basically just setting a default value to every single instance that gets created of this class. Does that answer your question?
Yeah, so you don't have to define it because all of them are going to have that, and it's not going to be different with all the different times you instantiate it with different values inputted it. Is that correct?
Yeah, that's correct. So I found a constant, which would be a place to store my contacts. But all of these are things that are not going to be constant. They're going to need to change, and that's the reason why it's like that.
Okay, thank you.
Of course, no
I have a
problem.
question.
Yeah, of course.
Can you?
No, go ahead. Sorry.
All right, so can you have the class anywhere else besides under the init functions? Like for instance, you can have the class here. That way you don't get confused. Because when I see it here, what I'm thinking about is part of this init method. So can you have the class anywhere here in a program, and you can have access to it at any time?
Anywhere here? Do you mean like on a different file?
Yes.
Okay, yeah, so you could definitely have a specific file where you can store all of your classes, right? And that way you could isolate that information, and then afterwards you can run an import statement. So let me see. Okay, so now I have notes2.py, and let me. Okay, so now from here I can say, from notes, import iPhone. And then I can say, well, I can still do the same thing, right? I can grab this information and place it there. And then when I still run notes2, it runs exactly the same. I'm just importing it from a separate file. Is that what you're asking, Abu? Okay, I think you said yes, but you're muted. But all right, perfect. And then let me bring this all back so that we still have it on the same file before I keep pushing forward. Okay, how would you add names to the contact? Would you then append a method? Yeah, so at that point we're going into methods, and we're not there yet, Jonathan. Thank you for thinking ahead, but we are moving, but we are not there yet. Let's see, Andrew. Oh, was there a question?
Sorry, I had one question. I was just curious as to why we put the optional self.contacts in the bottom versus being on the top, and just putting it as another option equals like we've done in others too.
Okay, so you're saying what's the difference between this and like why are these arguments up here, but this one isn't?
Sort of. I just remember in making a function, you can put an optional argument in there by just putting the equal sign in the top.
Yeah, so I can make it like a default argument, right? Where I can have the model be 5, and then this way I don't have to pass this, right?
Right.
Okay. Yeah, so I could do it this way, but this is setting a default value that it can default to if it does not receive an argument. This is not setting a default value. This is creating a constant attribute that will be constant across all instances. Does that make sense, Chris?
Yeah, that makes sense.
Okay, perfect. All right, does contact also have to be in the instance of the class in the init function, or can you just add it as an attribute? Andrew, are you referencing to line 7 here?
Yeah, I think I was thought I was asking kind of the same thing as Chris, although, yeah, just basically where context is on line 7. Does that have to be also in line 3, or is that something that you can just add as that attribute?
Yeah, so it doesn't have to be on line 3. If you think that there's going to be a different way that they're going to, I guess, have their format for their contacts, then maybe you could have it there. But for the phone that I'm designing, this is always how the contacts will be stored. So I took it outside of the init method, which is telling the user that they can't change it. This will always happen. Right? Every time I make an instance, there will always be a place for them to store their contacts, and it will always look like this. While all the arguments that are being passed in the init method, those are arguments that they can manipulate. Does that answer your question, Andrew?
Yeah, that makes sense. Thanks.
Of course. All right. Okay, so now we were able to go over the self method, and we were able to go over the init. Well, we went over self and we went over init. So let's see what else we got here. Oh, wow, they did a dog for the nodes. That's nice. All right, so now let's say, okay, so now we're gonna go into methods. Perfect. Well, the first method that I actually want to cover so that we're all able to see it is going to be the Dunder method. So the Dunder method is another Python built-in class method. And what you do is you do underscore str, and then you just pass in self. All right. Every single method that belongs to a class will always have the self be its first argument. Dunder Mifflin, yeah, okay. But this, and actually I didn't cover this, so let me go ahead and talk about it real quick. When this init method and this str method, well, the str method, all it does is it creates a way to represent the class and the instance of the class in a string rather than representing it with the memory space that we saw earlier. So let me actually clarify why we have these two underscores. So in Python, someone that was smarter than me and a long time ago decided that the way they were going to go ahead and separate all of their built-in functions that belong to classes was going to be with underscores. Well, the reasoning for that is because now, let's say my phone needs to be initialized, so it needs to have a way to be turned on. Well, I can create an init method, and you realize that there's no conflict here. They're not clashing into each other, and that's because of the two underscores that were prior to, right? These two underscores tell myself that this is something that doesn't belong to me, while this one that doesn't have any underscores is something that I created and placed into my class. Okay, so now moving back into the string. All right, so I have this method called Dunder method, and it's just creating a string representation for my class. Well, what I'm going to do is I'm going to go ahead and return something. And I'm going to return, let's say, the owner of the phone. So I have to do it with self.owner because self is referencing to the instance and then grabbing the owner. And then I can say has a model, or I can do self.model. Okay, so now when I run this, oh, it's not printing anything, of course. So now let me say print. So now when I run this, we see that instead of showing the memory space, it actually showed Francisco has a 6 model. Okay. Okay, let's see. Or is that the same thing? Is what the same thing? What is the difference between this method and the representation method? Okay, so the string method and the representation method. How do I explain it? It kind of just falls in hierarchy. The string method will be triggered first, and if the string method fails, then the representation method will take over. Does that answer your question, Ethan? Okay. And then how would you add names to contacts? Would you append method still work? Oh, I'll make that method right now for adding contacts. Give me a second. Okay, so now I have my phone and it has all this information. And maybe I just want to empty out this dictionary and have it empty, but I'm skipping forward. All right, so now I can see my phone and I can see that my phone is being represented now by Francisco has a 6 model. If I were to comment out my Dunder method and run this again, we see the encoded stuff. So I don't want this encoded stuff. It doesn't tell me anything useful. I don't have any idea what's actually stored here. So I'm just going to go ahead and create this Dunder method so that when I run my Python program, it gives me useful information, right? Notice I'm not exposing my phone number, not exposing anything vital like my contacts. I'm just saying the owner is Francisco and this is the model, right? It's kind of like when you click on my iPhone and it gives you that general information. All right. So that's the Dunder method. And we see that people want to see how you would add something into your contacts. So let's say that I wanted a method for adding into contacts. So add a contact, right? And again, it's going to take in self. And what I'm going to do is it's going to take in 2 arguments. It's going to take in the name of the person and the phone number of the person. And I'm just going to empty out this array, this dictionary, so that I can store anything in there. And I can say, all right, well, if somebody triggers this method, what I'm going to do is I'm going to grab my contacts. I'm going to pass in, or I'm going to say dot set default. So it's going to look for the name. And then it's going to give it a phone number. Is that really what I want? I don't think that's what I want. I more than likely want actual variable reassignment. So what I'm going to do is I'm going to say update. And then I'll pass in the name. And then I'll pass in the phone number as the 2 arguments. So let me make sure that's the way it works. Okay, I think that's the way it works. Let's see if this will work. So let's say I want to add my phone, I want to add it to contacts, and let's say I want to add Benjamin. So I'm going to go ahead and do a phone.owner. That's going to be the name. And then I'm going to do a phone.phone number. And that's going to give me the number. I'm not necessarily going to print that. Instead, what I'm going to do is I'm going to print my phone.contacts. Okay, so that didn't really work. It seems that the problem is at update. So expected at most 1 argument and got 2. So I have to clear up which method it is exactly that I want to use. But for the time being, I'm going to go ahead and pass name and make that equal to phone. Now, when I run this and I print out my phone.contacts, we see Benjamin is now part of my contacts and his phone number is saved onto my contacts. All right, so I created a behavior for being able to add a specific person along with their phone number onto my contacts for this instance. So now let's say that I print a phone.contacts. So this is Benjamin's phone. This is Francisco's phone. And when I run this, we're going to see that Francisco's phone has Benjamin inside of his contacts, but Benjamin's phone is still just an empty dictionary. All right, and that's creating a method. Does anyone have any questions over creating methods in OOP?
Why was a phone.contacts empty?
One more time.
Why was a phone.contacts empty?
So a phone.contacts, right? This is Benjamin's phone. It's an instance. So it's independent of Francisco's phone. All right. And let me actually change that so that it makes more sense.
you just pass like two strings? Because I think that's how normally you would add context, right? It would just be a name and phone number. You wouldn't normally pass another class into, or another class variable into a context, right?
Could you say your question one more time?
Yeah, I'm just thinking like I think that the confusion I think is like because when you add context, you just add two strings, like a name and a number, or a string and an integer, instead of adding another class instance as a contact,
Yeah,
which is confusing.
so just to clarify, I'm not adding another class instance. I'm adding the class's attributes.
Yeah.
But yes, I definitely get what you're saying.
Yep.
Okay. So now Francisco's phone is adding a contact into its contact list. And this is the instance that belongs to Francisco's phone. But Ben's phone never adds a contact, so his dictionary stays empty. And
That makes sense.
Okay, perfect. Thank you. How does the add a contact function know that neither of the arguments being passed when called is not referring to self? Okay, so the first argument will always be self, right? And what it's gonna do is when it sees that this is the instance, it takes the instance as its argument of self. It's a little confusing to explain, but I hope that kind of does it. Did that do it, Joshua? And if not, it's okay.
Yes, thank you.
Okay, perfect. All right, with the way you have it now, does it account for duplicates? It does not account for duplicates, right? So I would have to do something like Benjamin last name, or maybe I have to do a method where it says, hey, you already have a contact under this name, you can't add another one. Or maybe automatically, if it's already in there, it adds two. So I can say something like, if name in self.contacts, then self.contacts, and then I'm going to pass in an F string here. Or actually what I can do is say values. I could grab the key so I can get a list. And then I can say .count, and then I'll get the count of the name. And I'll make that to count, make that equal there. And then I can have self.contacts, make this into an F string, pass in the name, and please don't pay attention to this. If this is confusing, it's not important to understanding OOP. And then I could make that equal to the phone. Okay, so dict key doesn't work that way. Okay, it's fine. Don't get angry. I'll turn you into a list. Okay, there you go. So now I have the first Benjamin that was added. It has his phone number. Then but it actually replaces. Oh, it's because I didn't do else. That's important. Okay, there you go. So now I have the first Benjamin with all of his information still remaining of 7777, and his phone number still stays the same. And then the second Benjamin that was added, well, I created this method that says, hey, is this key inside of my dictionary? If it is inside of my dictionary, count how many of them there are, give me that count, and then we'll add it, right? So now if I make another one, let's do this one, 999. Ooh, it didn't overwrite it. Interesting. Oh, I see, because Benjamin 1 is now no longer a thing. Nice. Yeah, so this might be a little bit more complicated of a method than just doing this. But you would have to alter this information. You would have to alter this algorithm to make it be able to add specific Benjamins with how many numbers there are following on, or a way to separate them. Does that answer your question? Was that Ethan? Okay, perfect. All right. So that takes care of making a method. So we understand methods, and we already went over the Dunder method and what it does.
I do have a question.
Yeah, of course.
So I see that we're kind of repeating the information for Ben phone, and then we're adding in a contact. How would we like only have to enter in that information once if we know that that is his phone number and that's his name and that would be the contact?
How would we only have to enter this information once?
Yeah, because we have to enter it in, I see, we're doing it twice. Is there a way to do it just once?
I mean, if I had something like a list of numbers, I can technically iterate through the numbers and make those methods happen, right? But if you're talking about kind of like doing like star, let's say I have Ben's number and I make that equal to a dictionary, and the dictionary has a name, and that name is now Benjamin, and then it also has a phone, and that phone is, I don't know, I'm just gonna throw in some digits in there, right? I can also do something like Francisco's phone dot add contact, and then I can do star Ben phone. And we can see that when I run this, it's gonna throw an error. Must be a mapping, not an iPhone. Oh, I used the same. There you go. Hey, Ben's phone is not defined. Thought it is. Oh, it's because I said Ben's number. There you go. Eventually, I'll understand how to write Python. Okay, so now we see that it still passed in the arguments accordingly, and I was able to create the dictionary of contacts with Benjamin and the phone number that I passed into it. Is that more what you're heading towards?
Yeah, I just would only want to put that information in once for Ben.
Rather than doing it this way.
Yeah.
Okay, yeah, so I could, if I had a list of this information, then yeah, I could definitely do it this, I could definitely just iterate through the list and then throw the arguments as they come into this one method and then just call it one time. But the way we have the program set up, we would have to do it manually this way.
Okay.
Awesome. Okay, so in general, what is the purpose of the str function? So the main reason why I use it is just so that I can actually get information back that's useful. When I run, again, if I just run Francisco's phone and I take off my string method, when I do this, it just gives me back the memory space where it's located. And that's not useful to me at all. So instead, what I do is I make a string method that would tell me some useful information. And now when I run it, I can see which actual instance I'm working with. Does that answer your question?
Yes, thank you so much.
Of course. For add a contact, can you name this as necessary? And so we have an instance of self.contact, but if there was self.something, would we use add a something? Could you expand on that a little bit, Nicholas? Honestly, yeah.
Yeah, I was just curious if you could name it, whatever you have for that instance. I think kind of what Ben was saying in there. There's no explicit link between the name of the fields and methods. So if we had, self dot whatever it might be, you could name that accordingly to add a whatever.
Yeah, so I could, these are just variables, right? I could just call it, it whatever I want, and then I could just do self dot whatever. Yeah, and it still functions correctly. Is that what you were asking, Nick?
Yeah, it was. Thank you.
Okay. Yeah, of course, no problem. Yeah, you just whenever you're working in a class, this class is pretty small, but classes tend to get really big really easily. Let's see if there's something I can find. Maybe I can do something like that. Update. Okay, so that works. And if I click on this, nope, that didn't work. Sorry. There you go. Okay, so if I click on .update, we see that .update is not a class, but maybe that is. There you go. So now we see that we have this class, and unfortunately Python kind of took it away from us. It puts these dots there to represent that there's other logic that goes along with it. Honestly, this is a little bit too advanced Python for me, and I don't think I can explain it intelligently, so I'm not going to try to give you guys wrong information. But basically, classes get bigger and they get fatter as you go along. So the bigger they are, the more complex they become to understand. So whatever you do for variables, you want to make sure that whoever is, if somebody completely new that had never seen your code before, or somebody completely new to Python looked at your code base, could see it and understand what a function is supposed to do or what a variable is representing.
Hey, Francisco, I had a question. So the string method, when you printed that, you just said print Francisco phone, right? And that printed the thing, and it printed your information for it. But how does it know that if you wanted to move that entire object, like let's say you wanted to put Francisco phone into something else, into a list, how does it know to pull the object and not the string, not the str method?
Yeah, so whenever I go to print the actual instance from now on, if it has a string method, it will always print the string method for the instance instead of printing its memory space. So it's gonna grab the instance and it's gonna say, okay, well, this has a Dunder method. So this is the way we'll display it to whoever's using the terminal commands, right? So let's say I have let's say I print and then I do Francisco's phone and then I do Ben phone. Nope, that's not a command. There you go. I see. So this is messing it up. Is this what you were asking?
Yeah, basically. So if it's followed by a print, or if it's inside a print statement, it knows to grab the string, but anything else is just going to grab the object.
Yeah, it looks that way. So it's going to grab the representation of it within the string unless you iterate through it to be able to print it. So let me see, list of phones. Yeah, so if I print list of phones, I should just see. This is weird that I'm not able to use .values. I would have thought I would have been able to use it. Huh, interesting. Yeah, but I could, if I print list of phones, it's going to show me that list, right? But the list is only going to have the memory location on it. It's not going to actually have anything useful for me. So in order to see something useful, I would have to iterate through the list and then call the print statement. So I could do something like for phone and list of phones. And then
You can unpack the object.
unpack the object. Okay, we'll try that out right now. So you're saying I could unpack the object if I do it with the list?
Yes.
Okay. And that would just be, would that be just a star? I think that's just a star. I may be wrong. Oh, so I can't just unpack the object with just the star. And then it would print it this way. But I think when I'm doing this, it's not actually printing the list itself. As you can see, there's no commas. It's just printing all of the elements within it. So it would be the same as iterating through and then printing each individual one. It's just that instead of getting it in different lines, I'm just getting the first and second argument being passed into the print statement. Was that your question, Jesse?
Yeah, that was that's exactly what I was looking for. How does it know not to grab the object and grab that string instead?
Perfect. All right, so cool. Could you explain unpacking? Is the star essentially doing the same thing as the spread operator in JavaScript? Yes, Jake, and then Roger. Yeah, so basically by putting the star in here, I'm saying grab whatever it is that I'm passing following that star, and instead of representing it in a list, I want you to grab each individual element out of that list and bring it out as its independent argument. So this is actually the same thing as saying print Francisco's phone and Ben phone. This is the equivalent of doing line 24, and all I'm doing is grabbing the arguments from within the list and bringing them out to be independent. Does that answer your question, Roger? Okay, perfect. That's all I had.
Hey, Francisco, but if you didn't have that the string Dunder method in there and you spread it, would it still just return like the memory in code?
Yes, it would.
Okay, thanks.
Now that I erased it, if I run it, it returns the memory encode. All right. OP, it's a fun concept. Okay, and it actually looks like that's going to conclude our lesson. But before we conclude our lesson, I would like to get a little bit of practice that's going to be student-led. So with that said, if we could, can somebody please walk me through creating a dog class? And in this dog class, what we're going to do is we're going to create a dog class that can bark, and this dog is going to, so let me see. Create a dog that takes in a name, breed, and age, and can bark. Okay, so how do we do that? Anybody could jump on, just go ahead and let's take a couple of shots at it.
Class dog with a capital D.
Okay, so class dog.
With a colon after it.
Def init, and then self, name, breed, age.
Okay, so init, and then
India, yeah, and the parameters.
so we want self, name, breed, and age. Okay. And then someone else.
You want it to bark, right?
I do want it to bark, yes.
So we probably need to put a bark in it. We probably need to put a sound or a...
So remember, there's
default.
Oh yeah, we could just make a default like the contacts, I guess.
Okay.
Self name.
We'll move back to the bark here, and then we'll set these attributes. Okay, so self.name, which is going to give the instance a name. What's the value that I'm going to give it?
It's your name.
Name.
And name.
And then self.breed. We can breed. Self.age. We set that to age.
Awesome. Okay, so now we got pretty much everything done. The only thing that we need is a bark. So I heard a couple of people saying that we could give bark as an attribute, and essentially we can. But remember, there's a difference between attributes, meaning parts of something, and then methods, which are actions. So bark is an action that a dog makes. So therefore it would fall as a method. So how could I make a bark?
Def.
Nice.
Yeah, define bark.
You need to do the underscores, right? Or no?
I don't need underscores.
No.
So you only use the underscores when you do the init in the beginning?
For a Dunder method, yes.
The init and the Dunder method, perfect. Yes.
And then we could make it like sounds, and then make a default, make it woof.
Could you leave it empty and then just put print bark or woof, whatever you need to say?
Yeah, that works. So print and then
You would just have to pass in self.
Good catch. Okay, so now we have bark, self. Okay, and now can anybody walk me through creating a Dunder method that would just tell me the name and age of this dog?
You go def underscore underscore str underscore underscore, and it would have self in the parentheses, and then a colon, and then enter, and you could do return f string. And you could say my name, or you could just put name. Yeah, or you do like my name is name, and my sound is bark.
You just have to reference the self, I think, in the curly
Yeah, you use
brackets.
Yeah, with the self.
Okay, and so if I put bark here for the sound, we would have to make this a return rather than a print. But again, this is our method. So here in this Dunder method, I want to know the name and the age. So I'm gonna go ahead and scratch this sound and do age, and then how do I grab the age out of this class?
Self.age.
Perfect. Okay, so now someone tell me how to instantiate a class, and let's give it a name, a breed, and age.
So you need to put the name of the dog.
Okay.
And then equals the class name, which is dog. So just put in like Rufus, or yeah. And then you have to put the attributes.
Okay.
Do we name him Francisco or Frankie?
You guys are naming after, all right, whatever.
And now
Yeah.
the name, the type, so poodle or something or whatever.
Don't give him poodle. Give him something like intimidating.
And what would be the age?
In
go
dog
15.
years, it's 50.
All right, 50. Okay. Awesome. So now, how do I make this dog? Can somebody tell me how do I make this dog bark?
My dog.bark.
Nice. Let me run this Python script real quick, see what it does. Okay, we see woof. Perfect. So the dog did bark. All right. How do I see the Dunder method of this dog?
Print my dog.
Yeah, and we'll see my name's Francisco and my age is 50. All right. And then how do I see the breed of this dog?
Print my dog.age.
Okay, so the age.
Breed?
Yeah, the breed. Let's do dot.
The breed.
Oh, yeah, sorry.
Now when I run this, I see poodle. Oh man, you guys. Okay, cool.
Killing you.
Yeah, there you go.
You're not getting out of that dog shelter. I'm telling you that right now.
All right, so now we have our dog. He's been fully created. So if I wanted to see the memory location where my dog is being saved, what do I have to change about this program?
The Dunder method.
Okay, what about it?
Comment it out.
Perfect. Now when I run it, we see the memory location. All right, great. So that's going to conclude our lesson for the day. Does anyone have any questions over anything that we went over today? Anything at all from beginning to end?
Is there a way to see it without commenting out that Dunder method?
Ooh, that is a good question. I actually don't know about that. Let's see. My dog dot.
Would you just have to have like a regular Dunder method where it just says like return self.name?
Well, yeah, but I think what he's asking is that if I did have a Dunder method, how could I make it print without the Dunder method? No, that's not it.
You just put it in the list.
Yeah,
Say print my dog in square brackets.
Yeah, I'm gonna have to get back to you on that one. I honestly don't know that one off the top of my head. I could cheat and just try to force it, but I don't think that's what we want. So I'll see if there's a way to do that, but I don't know that one off the top of my head. So you got me good.
But if you do put it in square brackets, can you try if it prints out?
Yeah. Like this?
Yeah, that should give you the address, right?
Yeah, it should. And it would just put it inside of a list.
Yeah. Okay, got it.
Perfect. Okay. So that is both of our notes. And let's see what we have today as well.
I also have a question.
go
For the under string method, that's just used to get like information about the object specifically, right?
Yeah, I mean, more specifically is to make sure that whenever you print my dog, instead of getting that weird memory location, you're getting something that you can actually work with that represents the instance, right? Because if I'm trying to manipulate multiple instances and all I'm getting back is just that serial number, nothing necessarily tells me that I'm working with the correct instance. So therefore, I make the Dunder method so that I can identify each individual instance. Does that make sense?
Okay, yeah. Thank you.
Of course. All right, so let me go ahead and take a look here just to make sure that I covered everything that was there for today's lesson. Okay, seems like everything for today's lesson was covered. We went over the Dunder method, we went over methods in general. So for today's assignment, we see app users 1 in Python being bold. I might change that to be highlighted. So I'm going to try to change this so that it gets so that it's highlighted. But basically, any assignment that you see that's bold, that's going to be the assignment that you'll be getting feedback from your TA. So this would be our priority assignment. And then after that, it's the guessing game and the CSV reader. Perfect. I'm going to go ahead and stop the recording.